This is the 4.7 Day 1 video for notes. We started a new section today. We are working on arithmetic sequences, which we found that as we worked through our notes today, that it is basically just a linear function. So we're going to go ahead and start with a problem that has a lot of concrete models involved and really walks you through this process. Okay, so it says use the figures to complete the table. Plot the points given by your completed table. So notice here that we have a table that says number of rows n, and they are given values 1, 2, 3, 4, 5. And then it says number of dots y. So using this concrete model, we filled in this bottom row of our table. So I see that the number of rows, when there is one row, there are 2 dots. When there are 2 rows, there are 4 dots. 3 rows is 6 dots. 4 rows is 8. And 5 rows was 10 dots. Okay? Now, when we talked today in class, we talked about the fact that the numbers that I just filled in, those are my actual sequence. So my sequence is 2, 4, 6, 8, 10. And some of you right away pointed out the fact that these were increasing by 2 every time. And we talked about the fact that these numbers are really just ordinal numbers. They're telling you that this is the first term in the sequence, the second term in the sequence, the third term in the sequence, the fourth, and the fifth. So yes, they're giving you a concrete model in order to kind of lay the foundation for this lesson, and they're calling this 1 row, 2 rows, and so on and so forth. Okay? So now we have a set of ordered pairs. I told you guys that n, or the position of a number in a sequence, is always going to represent your x value, and they already told us here that the number of dots was our y. So then we're going to graph that. Now, graphing on my iPad isn't the greatest, but you can see here that I have graphed a point at 1, 2, because in one row there were 2 dots. In 2 rows there were 4, 3 was 6, 4 was paired with 8, and 5 was paired with 10. And looking at my graph, if you are describing the pattern of those y values, you notice the y values are increasing by 2 every single time. Okay, so y increases by 2 each time. Now, if you're looking at the graph, what you should notice is that that creates a straight line. So I know that this is a linear pattern. And that should have been kind of already in your mind, because you know that if you have a constant rate of change, meaning these numbers are increasing by the same amount for every one of these, then that's going to be what creates a line on a graph. Okay? So then from here we moved on. And we talked about, okay, so what if they just give you the sequence? So it says graph the arithmetic sequence 4, 8, 12, 16. What do you notice? So this kind of takes us back to what I was talking to before. So the first thing that we did is we just made a t-chart. And we labeled it XY. And like I was telling you before, the numbers that are actually in your sequence represent your y values. So we filled those in as 4, 8, 12, 16. Then, just like on the last table, remember the x value, that's n, which is really just the position of the number in the sequence. So 4 is the first term in the sequence. 8 is your second term in the sequence. 12 is your third term in the sequence. And 16 is your fourth term in the sequence. Now you have an ordered pair that you can graph. Okay? So on my coordinate plane here, I am going to go by 1s on the x-axis, but I'm going to go by 4s on the y. So this is 4. Okay? So now I can graph. So 1 was paired with 4, 2 was paired with 8, 3 was paired with 12, and 4 was paired with 16. Now what you should notice is once again, we have that linear pattern. And once again, you should have been expecting that because you should have noticed that these were increasing by 4 every single time. So there's my common difference. So then we talked about the word or the definition or the vocabulary term, common difference. So a common difference is the difference between consecutive terms in a sequence, and we call that D. Now, based on what we've done on the last 2 examples, you should be able to answer this question. So it says, does the graph represent an arithmetic sequence? Well, I can see visually that it's linear, and I've noticed that every pattern that I've graphed has been linear. So I know, yes, this is an arithmetic sequence. We could say because it's linear, or we could be more specific and we notice that if you look for the difference in your y values, this is decreasing by 3 every single time. 15 to 12 is minus 3. 12 to 9 is minus 3. 9 to 6 is minus 3. So the common difference is equal to negative 3, which makes it arithmetic. Now at this point in the notes, this is where things started moving more algebraic as far as dealing with equations. So the first thing that we did is we discussed the equation of an arithmetic sequence. So when I taught you the equation, the way that we said it, because I made you repeat it after me several times, we said a sub n equals a sub 1 plus n minus 1 times d. But then in working with the equation, we noticed that when we were writing equations, the first thing we had to do was distribute this d. And some of you were struggling with distributing back like this. You didn't really like how it looked. So since we know that multiplication is commutative, I just moved the common difference in front. So this blue equation is the same as this green equation. A sub n is any number in your sequence. A sub 1, that's your first term. N is the position of the number in a sequence. And D is that common difference that we've been talking about. So then we worked an example. It says write an equation for the nth term of the arithmetic sequence. So that's where I'm going to start. So I'm going to start here and do step 1. So I'm utilizing the formula, the blue formula. So I'm looking for a sub n because it says for the nth term. A sub 1 in this sequence, so the sequence they gave me was 14, 11, 8, 5. So the first term was 14. So 14 plus, and I know I'm going to have n minus 1, but I need that common difference. So remember, that's the difference between consecutive terms. This is also decreasing by 3 every time. So what I'm going to do is I'm going to put my common difference in front. Okay? Now since I'm writing an equation, I know I need to simplify, so I'm going to distribute my negative 3. That gives me 14 minus 3n plus 3. Okay. Now I'm still not finished because I noticed that I have some like terms. I have a 14 and a positive 3 that can be combined. So I get a sub n equals negative 3n, and then 14 plus 3 is 17. So I've now written my equation to find any term within the sequence. I can find any number in the sequence using this equation, which is what they're asking me to do right here. So it says then find a sub 50. So we're looking for the 50th term. So I can find the 50th term simply by plugging in a 50 for n, because remember n is the position of the number in the sequence. I'm looking for the 50th term. So I have negative 3 times 50 plus 17. Negative 3 times 50 is negative 150, plus 17 will give me my 50th term, which happens to be negative 133. So I've now answered both of those questions. Okay, so in class today you did 3 more examples, and for the most part you guys seem to be understanding. Now, if you're not understanding or you have any questions or want any clarification, I'm available for tutoring in the morning, and we will finish up our notes on arithmetic sequences tomorrow, and you will have time to work on your homework. Don't forget to log on to bigideasmath.com to access your assignment. You guys have a great night.